Hello everyone, welcome to this question where we are required to find the area of this triangle. Okay? Well, since we are given the length of two sides and the included angle, meaning that two sides made that angle, and this is the configuration that we are looking at. A and B must make the angle. So in this case, we are looking at this length, and this length must make this angle C, which happens to be in between these two sides. And once we are able to get this configuration, then we are able to then apply the formula immediately. So area of this triangle, which is ABC, will be equals to half times 4 times 6 times the sine of 48 degrees. And this will give me a value of 8.9177 to about 5 significant figures, followed by 3 significant figure, 8.92, in this case, cm square. And we are done with this question, and let's move on to the next question. Hello everyone, welcome to this video where we are required to find the area of this triangle here. And knowing the formula of a triangle is half AB sine C, we do need to make sure that the angle C in this formula is made by that two sides, meaning this C is an included angle. Let's see. We are given this length, 9.9. We are also given 7. And when I look at this question, then I realize that, hey, the angle that is made by these two blue color line is actually angle LMN, which will be my included angle C in the formula to find area of a triangle. And so we should not and we cannot anyhow use other angle. This angle in this formula must be the included angle of the two sides. Okay? So in this case, I will then need to first find angle LMN, which is 180 degree minus away my 30 degree and my 45 degree, to give me a value of 105 degrees. Okay, this happened to be the angle sum of the triangle. Now, with this 105 degree, we can then apply the formula easily. So area of this triangle LMN is therefore equals to half times 9.9 times 7 times the sine of the angle, the included angle made by these two lengths, 105 degrees in this case, and this will give me a value of 33.469 to about 5 significant figures. Final answer, 3 significant figures. With that, we have come to the end of this question, and let's move on to the next question. Hello everyone, welcome to this question where we are given the rhombus. In this question, all the sides are equal. Find the area. Well, in this particular question, then it will be useful for us to note that we could actually draw a line here to break the rhombus into two equal triangles. And knowing that all the sides are equal, This will then be 7.5, 7.5. And then we are also given the area of a triangle is equals to half times A times B times sine of angle C, whereby this is the configuration. The length that is given must make the angle C. Okay, it's not any other angle, it is this included angle that is made by the two lengths that we are using. And since we are able to get that configuration, so the area of TXYZ of this rhombus would then be equals to half multiplied by 7.5 times 7.5 times the sine of 110 degree. This is only for one triangle. So if I need to have two triangles, what do you think I should do? Yes, I'm going to multiply by 2. And this will give me a value of 52.8577 to 6 significant figures. Final answer to be given in 3 significant figures. Sorry, this will be meter square. And we are done with this question. Let's move on to the next question. Hello everyone, welcome to this question where we are given in words triangle ABC, where AB and AC and angle BAC is given. Find the area and hence find the perpendicular distance of B to AC. Well, the best way to do and approach this question is by first and foremost, let's try and construct this sketch this triangle out. So AB is 11.7. AC is 12.8 and BAC is 74 degrees. Okay, so this will be useful when we are going to find the area of a triangle, since area of a triangle and in this case triangle ABC is given by this formula. And this formula requires us to take note that the length that we are using must make the angle that we are using as well. So this angle is to be the included angle. Okay, then this formula will work. So I will then have my 12.8 times 11.7 times the sine of 74 degrees. And I will get the area pretty straightforward. 71.979 to about 5 significant figures followed by 3 significant figures, 72.0 cm square. For part B, where we are now tasked to find the perpendicular distance from B to AC, meaning from B to AC, perpendicular distance will be something around here. Which is 90 degrees. Then since we already gotten the area, Of course, I'm going to use this area. Then, if I have the base and the height, then I could actually tap on another formula for area of a triangle, half time base time height, right? So I'm going to let this be h. So this is something that later on I will take note of. For part B question, I'm going to write as let h be the perpendicular distance from B to AC. Okay, and from here then I could then apply the formula easily, half time base. So in this case here my base will be 12.8. So I'm going to just cut this out so that it's easier for us to do at the other side. Okay, so I will have 12 times 8. This is my base, and this is my height of the triangle H. And I've gotten the area of the triangle from part A, 71.979. Notice Mr. Tan here did not use the 3 significant values. Rather, I used the 5 significant value for accuracy. Alright, and therefore from here I would then be able to get my H, which is simply 71.979 divided by half divided by 12.8, and I will get my answer as 11.2467 to 6 significant figure. Final answer 11.2. Alright, with that we have come to the end of this particular question, and let's move on to the next question. Hello everyone, welcome to this question where we are given BCD is a straight line. We are given parallel lines BA and CE, and the sides of AB and AC is 5 and 6 cm respectively, and some of the angles are shown in the diagram. Find the area of triangle ABC. We also know to find an area of a triangle ABC, if we know the sides. If you have 2 sides, in this case, we could actually use 5 and 6. And if we know the included angle, then we can apply the formula immediately. So now our question is, what is this angle BAC that we need to find out first? Well, the parallel lines allow us to see that, hey, these 2 angles is the same because they are alternate angles. Okay, so step 1 would then be to help us, it will be helpful if we know what is angle ACE, which is simply 180 minus away 70 and 65, because this is adjacent angle on a straight line. And I will get 45 degrees. And once I know this, and I will then be able to gather that this is also 45 degrees because they are alternate angle. So angle BAC is equals to angle ACE because they are alternate angles where the line BA and CE is parallel. And the moment I found out that this is 45 degree, I can then apply my formula. Which is half, going to multiply by 6 and 5. And again multiply by the sine of 45 degrees. To give me a value of 10.6066. 6 significant figures followed by 3 significant figures. And we are done. And let's move on to the next question. Everyone, welcome to this question where we are given that in a triangle ABC, BC and AB is given, and the area of this triangle is also given. Find two possible values of angle ABC. This means that there are two possible ways we can draw this triangle. Okay? One way would be this. So given BC, AB is 4 cm and BC is 6 cm. This is one possible way of the triangle. Another possible way is this as well. AB four, 6. And so there are two possible answers, okay? So one would be an acute angle ABC. One would be an obtuse angle ABC. So do take note later on, then you will see that we are going to apply what we previously learnt before, that the sine ratio of an obtuse angle is the same as the sine ratio of the acute angle. And then, since I know that this and this happens to be my included sides, and given the area already, then this is what Mr. Tan going to do. I'm going to apply straight to the formula. Half times 4 times 6 times the sine of this angle, which we don't know yet, but it could be either obtuse or acute, is equals to 11 cm square. And therefore, I will then be able to get my sine of this acute angle or obtuse angle. As such, 11 going to divide all the half, the 4 and the 6 to give me 11 over 12. And then from here, my angle ABC will be equals to the sine inverse of this. And do take note, when you key into your calculator will always give you the acute angle. Okay, so in this case, I would then have my acute angle 66.446 to find significant figure. But at the same time, do also take note that Angle ABC can also be an obtuse angle as shown above in my diagram. And we do know that this is what happens. As long as the obtuse and acute angle add up to 180, their ratio, sine ratio is the same. So I will have two answers. One is 66.4 degrees to 1 dp. And the other 113.6 degree to 1 dp. Alright? And these are the two possible answers in this question. So we must be careful when we deal with sine ratio. Alright? And we are done with this question, and let's move on to the next question. Hello everyone, welcome to this question where we are given a parallelogram ABCD. And we are also given the sides 3x and 2x. And the included angle 74 degrees. We are also given the area. Nice. Okay. So from this you can slowly see that you can see this. And if I were to cut this parallelogram into two equal triangles like this, then you can see that the area of the parallelogram is 2 times the area of the triangle ABD. Yes? Okay? And so, by applying the formula directly, this is what you will get. So I will have this half times 2x times 3x times the sine of 74 degrees. And this is one triangle. How many are there? I have one here, and then we'll have another here. So it is 2. So I times 2. And this will be equals to 100. Okay? So from here, then I could slowly simplify. Half times 2 is equals to 1. Therefore, 2 times 3 is 6. X times x is x squared. So you have 6x squared. I still multiply by the sine, 74 degree equals to 100. So my x squared will be equals to 100. I'm going to divide by 6 on both sides. I'm going to divide by sine, 74 degrees on both sides. So that I will get my x squared. And finally, my x is therefore equals to the square root of 100 over 6 times sine 74 degrees. And because x in this case has to be positive since we are dealing with length, I would just focus, the answer has to be the positive root of this expression inside, which will give me 4.1639 to about 5 SF, followed by 4.16 3 SF. And that is the value of x. And therefore, I did not write any unit. And let's move on to the last question. Hello everyone, welcome to this question where we are given a cross section of the heart in this diagram. Find the area. Well, it would be good for us to see that this is actually a triangle and a rectangle. So to find the area of this cross section. So to find the area of the cross section, all we have to do is to find the area of the triangle, where this is the included angle of these two sides. And I can apply the formula pretty straightforward. I also see that this is a rectangle. So to find the area, part A, area of the cross section, it is simply the area of the triangle, half times my two sides, times sine of the included angle, plus the area of the rectangle. And this will give me a value of 23.346 to 5 significant figures, followed by final answer, 23.3 meters square. As for part B, the height of D from AB, well, let me just draw that out. This will include 3 here, followed by this length. Which we could get easily because this happens to be the height of the triangle EDC. So for this question, right, step 1 of course is to let people know that we are going to let H be the height of triangle EDC. Okay, then the base, I'm going to use this 6, such that half times H times 6 and half times 4 times 3 times sine of 117 degree are the same, right? Therefore, I can find my H easily by having the half times 4 times 3 times sine of 117 degree. This whole thing dividing off by my half and my 6. And this will give me a value of 1.78201 to 6 significant figures. And therefore, my final answer when I go back to this question, the height of D from AB would then, I would need to add this additional 3. So final answer, the height of D from AB is therefore equals to 1.78201 plus 3, 4.78201, 4.78 meter to 3SF. And with that, we have come to the end of this video. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.